Hello, my name is Luffy Fendi from class TT4L, group 01, and today I'll be discussing Form 4, Chapter 1, Quadratic Functions and Equations. A quadratic equation is an equation where the highest power of the variable is 2 and has only one variable. This general equation is represented as ax squared plus bx plus c. So if we were to write it in a equation, it would be, let's say for example, if we insert the values of a, b, and c, let's just say 5x squared plus 7x plus c equals to 0. So if we were to identify a, b, and c, we would see that from the left side, a equals to 5, as we can see over here, b equals to 7, and c would equal to 1. If, let's say, this plus was a minus, then c would equal to negative 1. Alright, moving on. One thing that should also be noted is that b and c can both equal to 0, as in ax squared plus, let's say, 7 equals to 0, b would still be equal to 0, and even if c was not in the equation, c would still count as 0, and this would still count as a quadratic equation. Next, moving on to quadratic functions. Quadratic functions have a many-to-one relationship. Multiple values of x can relate to one value of y, but one value of x cannot relate to several values of y, because this is what's known as a function, a many-to-one relationship or a one-to-one relationship, but not a one-to-many relationship. If we were to visualize it, we have x here and y. Let's say we have values y, 5, and 7. And let's say we have values 2 and maybe 10. So if you were to relate these values, we would have maybe, let's say, 1 to 2 and maybe 5 to 2 and 7 to 10. What we have here is a many-to-one relationship because two values of x are relating to y. But if, let's say, we have 1 also relates to 10, this cannot count as a function. This is no longer a function, a quadratic function, because it is a one-to-many relationship. If we were to visualize this, let's say we take the value 1, so it will be f1 equals to 2, 2 being the value of y and the function 1 relating to 2. This is the object, this is the image. But f1 cannot also equal to 10 because it is impossible. Hopefully you can understand that and understand why in a quadratic function we cannot have a one-to-many relationship. Moving on. Traits of quadratic functions. Graph. Here we'll start with determining the shape of the graph. When a is more than 0, meaning a, the value of a within the quadratic equation, is positive, the graph curves downwards and has a minimum point. So let's do a graph curving downward, and this, as you can see, means that the value of a within the quadratic equation is more than 0 and has a minimum point roughly around here. And when a is less than 0, meaning a is negative, the graph curves upwards and has a maximum point. Let's just do this. Here would be a is less than 0, so this would have a maximum point, something like this. If we were to, let's say, try to memorize this, we can also see that maybe if it's a positive value of a, we can see it as its smiling face, and if it's a negative value of a, we could see it as a frowning face. Alright, hopefully you can understand that. Next, we'll move on to axis of symmetry. Axis of symmetry divides the graph into two parts of equal size and shape. This can be found by identifying the minimum and maximum points of the function. So what does this mean? Let's say we have a graph and we were to find the axis of symmetry. This would be the section that divides the graph into two equal sizes, into two parts of equal size and shape. Let's assume this is a perfect looking graph and is perfectly equal in size and shape. This right here, this line would be the axis of symmetry, and if we were to find this line, axis of symmetry would be we would need to identify the minimum or the maximum point depending on what kind of graph it is, what kind of graph shape it is. So if the minimum point for here would be, let's say, 1, and the y value, let's say it's 0, we'll make it this. Sure, why not? Let's just do 1 and here's 2. Why not? The axis of symmetry would equal to 1. This is, we will take the x value and this will be our axis of symmetry. Alright, next we have value of limits. This is pretty simple. When a is more than 0, y has a minimum value of k, and when a is less than 0, y has a maximum value of k. This means that when a is less than 0, when a is more than 0, the minimum value of k is this section right here. This would be k, in which the value of y cannot get any lower than this. Same with this. The value of y cannot get any higher than this because of the way the graph function is formed. It cannot get any higher than k, and it cannot get any higher than k over here when a is positive. Alright, next we have the effects of values a, b, and c towards quadratic function graph. So this is pretty simple. The value a will determine the shape of the graph as we've discussed previously. Value b determines the position of the axis of symmetry, meaning the position of the graph across the horizontally across the x-axis. Maybe it's here, maybe it's here, maybe it's here. This all depends on the value of b. Value of c determines the y-intercept. What does this mean? The y-intercept is where the graph meets with the at the y-axis. This right here would be the y-intercept, aka this would be the value c. So how do we find the value of c? Let's say we have the function fx equals to ax squared plus bx plus c. Of course, the value of c requires that the coordinates traveled along the graph. So let's say we have the values of fx equals to 4x squared minus 4x plus c, and that crosses the coordinates 2 and 5. If we were to insert this into the expression, we would have fx equals to 5 because fx is equal to y and y is 5, so fx equals to 5. For x squared, we insert the value of x, which would be 2. 4 multiplied by 2 squared minus 4 2, because this also goes into this value of x is the same, plus c will be the unknown, and we have 2 squared, which is 4. 4 times 4 is 16. 4 times 2 is negative 4 times 2 is negative 8. So 16 minus 8 is 8. 5 minus 8 is negative 3. So c equals to negative 3. Thus, fx equals to 4x squared minus 4x minus 3. This would be the complete quadratic function. And this is how we can find the value of c, by inserting the coordinates that are traveled along the graph. Okay, moving on to roots. So roots of a quadratic equation are values of x that satisfy said quadratic equation. Generally speaking, a quadratic equation has at most 2 roots, and it can have at least one root, or perhaps no roots at all. So, to find the root of the quadratic equation, there are many ways to find this. One way that I will teach would be the cross multiply method. So take this, remove this. Now, let's say given 6x squared plus 5x minus 4 equals 0, find the roots. First step would be to factorize. Like I've said, there are multiple ways to factorize quadratic equations, but one method that I will teach you is cross multiplying. So let's just take 6x squared plus 5x minus 4 equals to 0. So to use the cross multiply method, we just take the value of a and the value of c, and we try to see what numbers can multiply to result these two values right here. So for number 6, we can have 1 times 6. We can also have 2 times 3, and that's pretty much it. And for 4, we can have 1 times 4, or maybe 2 times 2. And for now, we just ignore the positive or negative values found in the equation. For now, we'll just ignore it. We'll get back to it later. So what do we do with these numbers? Well, what we have to do is we need to find what where we cross multiply can result in the number in the value for b here, which would be 5. To do this, it will require lots of trial and error. However, for the sake of time, I will get straight away to the answer. Let's just assume we've done this through multiple times through trial and error, and we get 2, 3 right here. We'll put it in the first column, and the second column will be the value for would be the multiplications to get the value c, and we take 1 and 4, this one up here and this one down here. So what we do with this, we'll make a line over here, is we cross multiply. We get 2 times 4, which is 8, and we take 3 times 1, which is 3. Can these two numbers, either by subtracting or addition, result in the number 5? The answer is yes. And how do we get subtraction? How do we get the number 5? Via subtraction, meaning one of these values has to result in a negative. So 2 times 4, should it be negative 8 plus 3? No, that can't be the case, because that would result in negative 5. So can it be 3 times 1? The answer is yes, because 8 minus 3 can result in the number 5. Now, which one would be negative? Would it be the number 3 or would it be the number 1? The way to find this is that we look at the number over here. If we make 3 becomes negative, then 2 times negative 3 would actually result in negative 6, not positive 6, so it cannot possibly be the number 3. But what about number 1? Can negative 1 times 4 result in the value of c? The answer is yes, because the value c is negative 4. Thus, the number 1 has to have a negative value. So this is how we find the value, the factorization to result in the number 5. And so if we were to put this into these pre-made brackets, the way to do this is we take the numbers from the first column and put them on the left side of each bracket, and the numbers from the second column and put them on each side of the second bracket. And then we add x over here, x over here, and this would be positive 4, and this would be negative 1. So let's see, let's double check. Can this over here result in this? So positive 2 times positive 3 result in positive 6? Yes. Positive 2 multiplied by positive 4 result in 8x. let's just write that down for now. 6x plus 8x, excuse me, 6x squared plus 8x. So let's put this negative 1 times 3x. Let's just put this over here. And negative 1 times 4, which results in negative 4. And we put a equals to 0 over here, just to show that this is a quadratic equation. So let's simplify this further. 6x squared plus 8 minus 3 is positive 5, plus 5x minus 4 equals to 0. Put equals to 0 over here as well, in case we forget. So the answer is yes, it is. This and this are exactly the same, which means this is correct. So what do we do next? What is the next step? Let's remove this, and then we remove these lines over here. After we have factorized the equation, the next thing to do is we find the value for x. So how do we do this? To find the value for x, we simply take these two columns. We do 2x minus 1 equals 0. We also take 3x plus 4 equals 0. So we have to find the value of x for each side. 2x equals 1, and then we move 2 over to the other side. 1 equals 2, x equals to 1 over 2. Same over here. 3x equals to negative 4, and x move 4 over to the other side, move 3 to the other side. X equals to negative 4 over 3. And that is how you find the two values of x, the roots of the equation. Now, hopefully you can understand that, and then we will move on to the next one. When or if the quadratic equation cannot be factored, we must use what is known as the quadratic formula. This is x equals to negative b plus minus square root b squared minus 4ac divided by 2a. This will be used to identify both the values of x. So let's take this equation right here, which is an equation that cannot be factored. So what we must do is we take the values of each side. Negative b, which would be negative 7. This is the value of b, which is negative 7. Square root negative 7 squared minus 4. A is 1 and c is negative 3. We'll close this off, divided by 2, negative 3, bracket negative 3. I almost forgot the plus minus over here. Alright, so let's simplify this even further to better understand. Now we now have 7 plus minus 49 minus negative 4 times negative 3, 12 plus 12 divided by negative 6. So let's put this into a calculator. Alright, so actually when we reach this point, what we'll have to do is we take either plus and minus and we separate them into two. So for this side, we take 7 plus square root 61, because 49 plus 12 equals to 61, divide by negative 6. This will give us our first value of x. So 7 plus square root 61, we put this into a calculator and then divide by excuse me, I'm mistaken. It's actually value of a is actually 1, not negative 3. Let's put this in and we will get 7.4051. This is our first value of x. And then next what we want to do is search for the value of our second x, which is 7 minus square root 61 divided by 2. And so if we put this into a calculator, we will get the value of x2 is negative 0.4051. And so this is how you solve for to achieve the two values of x, also known as the roots, for equations that you cannot factorize. And finally, you move on to drawing the graph. So to draw the graph, we take the function, and the first step would be to determine the graph shape. Based on the value of a, as we've discussed before, we will determine whether it is a smile or frown. Let's say the value of a is negative. We'll make it a little frown like this. Next, we determine the y-intercept c. Let's just say, I don't know. We make the c-intercept, let's say, right around here. And then determine the x-intercepts, also known as the roots, by using fx equals to 0. Let's say the roots, because it's a, because we, let's just say we're using a negative value of a, it'll curve like this, and then determine the midpoint h. So let's just say the midpoint h is around here, and so it would be like this. And this is how you draw for the graph. And this is how you draw the graph for a quadratic function. And so that ends our video. Thank you very much for watching.